Hi, welcome to Shiko Math Practice Lab, Learning Through Practicing. And welcome back. So in this video, we are going to do a set number 5 practice. In this set, we're going to talk about basically 3 topics. So the first topic is a test for divergences. And then the second topic here is like if you have two convergent series. So the sum and the differences or scalar multiplication, are they still convergent? How do we do that? Okay, and then the last topic is here. We want to do is change the repeating decimals to fractions. Okay, so now let's take a look the set of the problems we're going to cover here. So the group 1, we have 9 problems. We determine whether the series is convergent or divergent. If it is convergent, find its sums here. Then the group 2 here is kind of a very special applications here, right? So it's a special application about the geometric series, how to express the repeated decimals and into the fractions or into the ratio of the integers here. Okay, as always, you can pause your video and go ahead, try to practice these problems by yourself first. And when you finish, and then resume it, and then we can check the answers together. Okay, and now I'm going to go into the whiteboard right now. Hi, everybody, and welcome back. I hope you get a chance to work on some of the problems we list in our front cover pages here. Okay, so let's start. So like we talked about, we have 3 different topics here, right? So let's do a very quick review and what we are talking about. So the first thing here is, which said is the test for the what? Divergences here. In fact, I always told my students when you do a series, you want to see a divergence or convergence. And the first thing is I will always do a test of divergences because you try to find a series is not a convergence. Sometimes it's easier than try to prove the series is convergence here, right? So that's why, I always like the test of divergences. So I always tell my students, say, hey, go ahead, do a test of divergence and to see, is it divergent or convergence, right? I cannot say it's a convergent. I said, we definitely can see it's divergent or not. So what is the test for the divergence here? So this is what is our test, if you remember that. So this is n to the 1 to infinity, the an's, right? So the divergence test is really pretty easy. That means if you let the n approach to infinity, an, if this an is not equal to 0, okay, then we definitely will say this is a divergent series, right? So this is a divergent series. Okay, so it's very important to say if it's not equal to 0, we say it's a divergence here. And there are a lot of students very, very confused about this fact here. So if you have a limit n approach to infinity, if an approach to 0, okay, if the an approach to 0, I cannot right? So I cannot make a conclusion, cannot conclude is convergence here. Okay, so this is the place a lot of students make mistakes when they see the series and then you just say, oh, the limit an approach to 0, then this is a convergent series. That's not true because one of the most famous series, we call it the harmonic. I hope that you guys still remember. The harmonic series is like n from 1 to infinity, 1 over n, right? So if you say limit n approach to infinity, 1 over n, this is definitely is approach to 0. But I know the harmonic is what type of series? Is a divergent series, right? So be very, very careful here. If this one's here, you cannot conclude, right? You cannot conclude it is a convergent if the limit an. But if it's not equal to 0, then you definitely say, hey, this is a divergence here. So that's why I say it's easy. But if you get equal to 0, then you might need to take a look at the other tests here. Then the second concept we're going to kind of combined with this together is if you have two series, if it's both of them is a convergence. So for example, like if you can an plus bn, and then, if you separate them out, so this is an, let's do a plus minus. You can do plus minus, right? So this is plus minus n to infinity bn. Right? So if A and BM both is convergence, then it will be convergent. If one of them is divergent, so if you add some divergent to convergence, so it will be divergence here, right? So that's why we said add subtraction, or you do some scalar multiplication. What I mean, the scalar multiplication. So if you have n from 1 to infinity, if you have c times an, so this will be c times n from 1 to infinity to an. So if an is convergent, then the summation can is convergent. If an is divergent, then the summation of the can is divergence here, right? Okay, so now this is just a brief review, and I assume you already, your teacher already went through all the theories with you. So right now, let's just come to practice part, right? Okay, so now let's take a look. Like I say, like a typical, when I told my student, you test a series is convergent or divergent. The first test I'm always going to apply is I want to test for the divergences because it's easy. So if it's not equal to 0, then you can say, hey, this is a divergence here, right? Okay, so let's take a look at some of the problems. And so this is n from 1 to infinity. And this is 2 plus n. This is 1 minus 2n's here, right? So like I say, I always want to do a divergent test. So my an is equal to 2 plus n, 1 plus 1 minus 2n's, right? I want to find the limit n approach to infinity, an's here. So it's a limit n approach to infinity, 2 plus n, 1 minus 2n. Okay, so you can divide by n on both numerator and denominator. So this is 2 plus n plus 1, 1 minus 1 over n minus 2, right? So you divide n both sides and then see what happens. So when n approach to infinity, what is this numbers going to? Will approach to zeros, right? It's because the denominator becomes super big. Then what is this number going to become to? Is also become to zeros also. So I know when the limit n approach to infinity, this number going to approach to -1/2. So what happened to the -1/2? Hey, it's not equal to 0. So what happened to this series here? N from 1 to infinity. So this is a 2 plus n, 1 minus 2n. What happens here? This is divergent series, right? So that's why I said the test for divergence is pretty easy. Okay, so let's take a look at part B here. Part B, I have a summations k from 1 to infinity. So this is the k square, and this is a k square minus 2k plus 5. So let's say the a, oh, you want to say k, we can do k. So ak is k square minus 2k plus 5, right? Now I limit k approach to infinity, I have a k squared minus 2k plus 5. Same old, what I need to do? I need to divide by k squared both sides. So top would be 1. So this is 1 minus 2 over k plus 5 over k squares, right? So this is a divided what? Divide k squared both, right? Both on the denominator and the numerator. Now take a look. When the k going to pretty big, what happened to this term? This term approach to 0. What happened to this term? This term approach to 0. So see what you have here? So now you will have 1 over 1. Oh, it's not equal to 0. So what happens here? Because for the test of divergence, it's k is 1 to infinity, k squared. So this is a k squared minus 2k plus 5. So what type of a series this one? This is a divergent series, right? So let's see here. That's the test of the divergence. It's a very easy test. Okay, so now let's take a look at problem C here. So the C is the problem right out for you. So this is 1/3 plus 2 ninths and plus 1 over 27, then plus 2 over 81, then plus 1 over 243, then plus 2 over 729. So like a good detective, you see, what type of the pattern I have. So you see here, you see, hey, this series, it seems I can, so here, right? So it seems I can rewrite them into two different ones here. Right, so from your detective eyes, you can say, okay, so this one here, I rearrange my purple one. So this is 1/3 plus 1 over 27 plus 1 over 243. Seems this is one pattern, right? And now I adding my blue one. This is 2 over 9 and plus so 2 over 9 plus 2 over 81 plus 2 over 729 and right? So now in here, you can see here, right? So from, like we said, we always do a detective work. So from here to here, you find out that the ratio is 1 over 9. The ratio is 1 over 9. And now let's take a look what is here. So from here to here, you find out, oh, here the ratio is 1 over 9 also. Here is the ratio is 1 over 9 also. Okay, so now let's try to, now what type of series we are dealing with here? It's geometrics, right? So geometrics that are 1 over 9 is less than 1, so we know it's a convergent. So remember we did in the previous one, you factor the 1/3 out, so this will be what? 1 over 9 and 1 over 81, right? So this is 243, right? Okay, 1 over 81, Then here you can factor the 2 over 9 out. So this is 1 over 9 plus 1 over what? So this is the 1 over and 81, right? And Okay, so now I can use geometric series. So this one's here, this is my pink one. So the pink one, the result will be 1/3, 1 minus r, right? So it's 1 minus 1 over 9. So I can get a 3/8. And then this is my blue one. I can get this is a 2 over 9, then it's 1 minus r, so it's 1 minus 9 here. So what do I have here? I have a 1/4. So this is back to what we said. Both of this This is a convergence, right? So this is a convergent series. And this is a convergence also. So we said, hey, if two convergent series, then we add it up, it is what? Convergent. So I know the whole series is a convergent series, right? So this is a convergent series. Where it converges to? It converges to, you just 3/8 plus 1/4. So what is the converge to? 5/8 here, right? Okay, so in here, it's kind of like interesting. We'll just show you, when you have two convergent series, then when you add them together, it's still convergence here. Okay, so the part D is doing the similar things here. So right now we should be pretty familiar with these terms here. So this is n from 1 to what? 1 to infinity. So this is the pointer, negative 0.2 to the n, and this is plus 0.6 to the n minus 1. So both of them, they are geometric series, right? So we just need to be a little bit careful about the terms here, right? So let's separate this one out. This is 0.2. And this is n plus, this is a summation, n from 1 to infinity. This is 0.6 n minus 1. Okay, so let's take a look at this one. When n is equal to 1, this will be negative 0.2. When n equal to 2, is 2 to the negative 1 power, 1 negative 1 to the 2 power is a positive. So it's 0.2 to the second. Then minus 0.2 to the third, right? So dot, 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 dot. So the first one's here, my pink one's here, right? It's alternating here. Okay, now I'm adding the second one's here. So when n is equal to 1, you have 1 minus 1 is 0, so it's 1. N equal to 2, so it's 2 minus 1 is 1, so it's 0.6 to the first power. N equal to 3 is 0.6 to the second power, da, 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 right? So both of them, so this is my blue one. So both of them here, they are what type of a series? Geometric, because this one's here, the r is equal to the negative 0.2, but the absolute value of r is 0.2, is less than 1. So it's a convergence here, right? And here, this one, the r is equal to the 0.6, is less than 1. So both of them is convergent. Okay, then be very careful here, right? What I need to do here, I need to, because I need to have 1 plus r squared in order to use geometric series. So I need to factor out the negative 0.2. Right? So when you factor out the negative 0.2, the first term you have a positive. So it's 1 minus 0.2, then plus 0.2 to the what? To the seconds, right? And then minus 0.2 to the third, right? Da, da, da. And then the second term is okay. So this is 1 plus 6.66 squared, da, da, da. Now I can use the geometric series. So first one here is negative 0.2. So it's 1 minus r. Be careful about the negative sign. So it's 1 minus 0.2, right? Okay, so now this one's here. So this one is just 1 over 1 minus 0.6, correct? So this one, if you simplify this one a little bit, I think this one is a negative 1/6 plus, this one is 5 over 2. So the final answer is 7 over 3. So that means this series is what type of the series? So this is a convergent series, right? So this is a convergent series. And which number it converging to? It converging to 7 over 3 here, all right? So now let's take a look at the next ones here. So let's take a look at part E here. the problem, the part E, so this is a summation n from 1 to infinity. So this is En, and this is 2 to the n plus 4 to the n's here. So when we try to solve this type of problems, so the first, let's break this one into the two series here. So I can change this to the En to the n plus summation n from 1 to infinity. And this is the En to the 4n's, right? Okay, so like this one's here. So this one's here, then I can do a little bit here. So this is n from 1 to infinity. So this is E2, then this is n plus the summation n from 1 to infinity. This is the 4e to the n's here. Okay, so like in here, the first things, let's take a look these terms here. So this term, if limit n approach to infinity, 2 over e to the n's, I know e is 2.7182. So this one will go into 0. Remember, when it go to 0, we don't know, right? So I don't know this is a convergence or divergence. Remember that we talked about in the first page, we said that when it approach to 0, it might be convergent or might be divergent. So I don't know. So that's fine. So the first term doesn't give us any information. Okay, now the next terms here is n approach to infinity is 4 to the e to the n's power. So I know the E is 2.7182, right? So this one is greater than 1. So I know this number going to approach to what? Approach to infinity, right? So it's not equal to 0. So by the divergent series test, I know this part is what? This part is divergence. So if one of them is divergent, when you add them up, so this one is divergence here. Okay? So it's kind of like the interesting, right? Okay, now the last one I'm going to cover, instead of cover too many problems in one video, this is the last one we're going to cover, and then we'll be able to do the second part to cover another 6 problems here. Okay, so this one's here is a summation n from 1 to infinity sine 100 to the k. So the problem uses k. So let's just try to match the k so you don't get you confused, the k. Okay, so if you write this out, so you will say k equal to 1, you will get a sine 100. Plus k equal to 2, you will have a sine 100 to the square, right? K equal to 3, you have a sine 100 to the cube. Then da, 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 da. So now you see, okay, so from here to here, there's a ratio. This is a sine 100. You just times sine 100. And this is another sine 100 here. So you know your R is equal to sine 100, right? So let's take a look at the absolute value of R is R. The absolute value of the R is the absolute value of the sine 100. And I know the sine functions, right? So the sine function is the sine 100 is less than 1 here, right? Because the sine 100 here, if you put it into your calculator, this one is close to negative 0.506. So I know this is less than 1. Oh, so what is here? By the geometric, I know this is what? Convergent series. Then you say, yeah, this is geometric. I can use the geometric formula. Before we use it, I need to take it out of the 100. So I need to change it to the term 1 plus r squared, right? So this is 1. So what happened to the second term? will be sine 100. What happened to the third term will be sine 100 to the square, da, 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 da. So now this one's here will be sine 100 and times 1 minus r is sine 100 here, right? And so if you put it into the calculator, so it will give you something close to the negative 0.336. Okay, and so I think right now is probably is a good place to stop. I don't want to overwhelm you with one video. So we finish 6 problems. So we have the let's try to do the next 6 problems in the next videos here, right? Okay, so remember what? Practicing, practicing, practicing. That's the key to be successful in the math here. It's nice to talk to you and hope to see you in the next video. We're going to do more divergence testing, and then we're going to see how do I change the repeating decimals to fractions. Okay, nice to talk to you. Have a good day.